All right, guys, section 1.5 is all about measuring angles, and I'm sure you'll see as we get started with the section, you will be familiar with some of the terms that I'm going to introduce to you for section 1.5. So the first thing we want to talk about are the types of angles we are going to be measuring. We can be measuring an acute angle, which means that the angles measure is between 0 and 90 degrees. So it's we're going to write this as an inequality. 0 is less than our angle measure, call it A, which is less than 90. So it's anything between 0 and 90 degrees. And I'll put that here. Okay, so anything between 0 and 90 degrees is what we call an acute angle. People kind of see this word like cute in the name, and they think of it as being like little less than 90 degrees. Then we have something called a right angle, which we did talk about when we talked about lines that intersect that are perpendicular. They intersect to form a right angle, and that's because an angle's measure is exactly 90 degrees if it's right. Okay, so we have acute, we have right, and then we do have obtuse, which an obtuse angle measures, it's going to be greater than 90, so it's going to be in between 90, but it's going to be less than 180. Okay, so it's between 90 and 180 degrees, because we do have a special classification that is a straight angle, and this is when an angle measures exactly 180 degrees. So think of it as like a straight line. We've made one complete turn from this point here to this point here, so it's an exact, the measure of that angle is exactly 180 degrees. So you should know these four terms: acute, right, straight, and obtuse. So if you were looking at an angle, and let's say I give you a measure of 88 degrees, you should know that that's acute. If I say 180 degrees, that should be a straight angle. If I say 90, you should know that's a right angle. And if I say something like 150, that's an obtuse angle. So you should just be able to know by the angles measure what the classification of the angle is. So when we name angles, there's a couple of rules. We can choose to name them only by the vertex. But if there's more than one angle in the diagram, then we have to choose a point on the side of the angle, followed by the vertex, followed by a point on the other side. So let's look at how this works. If I were naming this angle number 1, I could name it angle Q, and that's the sign for angle, is that little sideways V, because I'm just naming it by its vertex. I could name it angle PQR. I'm starting with point P, which is on one side of the angle, point Q is the vertex, and then point R is on the other side. Or I could name it angle RQP. These are the three different ways to name the angle right here. This one, the number 2, we can actually name this angle 4 different ways, because sometimes your book will put a little 1 in the corner there. So if I'm just talking about angle 1, sometimes I'll do that. It's a lot easier just to recognize that I'm talking about angle 1. I could name this angle Y just by its vertex. We could do X, Y, Z. And then I want you guys on your notes to see if you can come up with the 4th way to name this angle that I haven't listed here. For number 3, I want you to name the angle in 3 different, or actually this one can be named in 4 different ways. So on your notes, so that way we can look at them together when I see you on Tuesday or Wednesday, or virtually, there's going to be 4 ways that you can name this angle. I want you to write them down here. And the reason why there's 4 ways in this one compared to number 1 is because I have that little 2 in the corner there, which allows us to name this angle just angle 2, where this one did not have a number. So adjacent angles. Adjacent means right next to, and in our case, for angles to be adjacent, they actually have to share a common side. So they have to share a side for them to be adjacent angles. So if I were looking at this, these angles in the diagram here, this would be a case where I don't just want to name, let's say, this angle. Let me change colors here. If I were just talking about this angle right here, So this guy, I wouldn't just want to name him angle Q because I don't know what angle you're talking about. Am I talking about just from this little section here? Am I talking about the section over here to the right? Or am I talking about the whole thing? So in this case, we want to talk about all the angles, all the angles with the more specific name. So in this diagram, I see angle PQR, which is the angle I've highlighted. I see angle RQS, which would be the other side, which would be this guy. Think of this part, just how we had when we had a segment, we had two smaller pieces equal the whole thing. And then the entire angle would be PQS, which would be the entire opening from here all the way to here. So there's technically three angles in the diagram, just like what happened when we were working with segments. So the adjacent angles would be the yellow angle, PQR, and then the blue angle, RQS, because they are right next to each other and they share a common side. I don't want you guys to get confused. If I were to draw two angles like this, if I were to draw like an angle here and then an angle here, these are not adjacent angles. These are not adjacent because they don't share a side. So they look adjacent because they're right next to each other, but they'd have to have a side in common. So like if I were to draw another ray here, then angle 1 and angle 2, these would be adjacent, but nothing to do with this angle here on the left. So if we're trying to find the measure of angle bad, which angle bad is the entire thing, this works just like the segment addition postulate. This is actually called the angle addition postulate. Because I'm taking a smaller piece, I'm taking just from here to here, and I'm adding it with this little section here to get the bigger angle. So I could write it out just like we did the segment addition postulate. I could say angle BAC plus angle CAD is equal to the measure of angle bad. And then I could substitute in. Well, angle BAC is 31 degrees. The measure of angle CAD is 24, and that's what I'm trying to solve for, is angle BAD. So 31 plus 24 is 55. So that means the measure of angle BAD equals 55 degrees. Now, if you don't want to write out degrees, we use a little circle. So if I were to put a little circle above here, this is our symbol for degrees. You can just put it right above the number. And for measure, we put a little M in front of the angle sign to read that as the measure of angle BAD. Okay, so this would be where we come into using the angle addition postulate, but variables are included now. So if I were to put a little 1 right here, let me change this to purple. If I put a little 1 here, and I'm going to put a 2. So just to make our life a little bit easier, I'm going to put a 1 there. I'm going to put a 2 here. So when I write a statement, I know the measure of angle 1 plus the measure of angle 2 is equal to the whole thing, which is EDC. Okay, again, a little piece plus little piece equals whole piece. So then if I go to plug in 21x minus 5 plus 10x minus 3, it's equal to the whole thing. And we have this given information up here that the whole thing is 147. Now, if you notice something, I worded the whole angle as EDC, but they worded it as CDE. It doesn't matter, remember, because the vertex is in the middle and a point on either side of the angles on the left and the right. So these two are two different ways to name the same angle. So now I'm just going to combine like terms. So on the left-hand side, I'm going to combine 21x and 10x to get 31x. And negative 5 plus negative 3 is negative 8, and that's equal to 147. Now I'm going to add 8 to each side, so I get 31x equals 155. Then when I divide both sides by 31, I get x is equal to 5. So that's exactly what we did with segment addition postulate. Now we're using it with angle addition postulate. And if I scroll back up to what it was asking, it said find the measure of angle YDE, which in our case, YDE is this guy here, angle 1. So I'm going to plug in 21, x is 5, so I'm replacing x with 5 minus 5. So 21 times 5 is 105. 105 minus 5 equals 100. So that must mean angle YDE, the measure of angle YDE, equals 100 degrees. And we'll put that little circle above there. So what does that mean for if we had to classify this angle? Would this angle be acute, right, or obtuse? YDE. You should have said obtuse. It's an obtuse angle because it's more than 90, but it's less than 180. The other angle, angle 2 here, I could just get by subtracting 147 minus 100, and that would give me 47. So angle 2 must be an acute angle. Now this one here, I'm just going to help get you guys set up, and you're actually going to solve it on your own. So this one would work the exact same way. If I'm trying to find x and then find the measure of PRQ and QRS. So this would work the exact same way using the angle addition postulate. I'd have angle PQR plus PRQ plus angle SRQ, and that's equal to the whole thing, angle PRS. So if we start plugging in our information, angle PRQ is 6x plus 13, and angle SRQ is 3x minus 4. You notice that it doesn't give us what the whole angle was, so I don't know what to set it equal to. Well, if you recognize this angle right here is a straight angle. So if we remember what a straight angle's measure is, then we know we can plug it in for 180 degrees. So sometimes you might actually have to recognize what kind of angle the whole thing is so you know what to set it equal to on the right-hand side. They'll do this for you too sometimes if they give you a right angle. So if they give you a right angle here, again, it would have to be labeled because of the box. And then they break it up and it doesn't tell you what the sum is. Well, you automatically know you would set it equal to 90 degrees because of it being a right angle. So just watch out for that. So what I want you guys to do now is solve this equation for x, and then you'll need to plug it into PRQ and SRQ, or QRS. The last thing we're going to talk about are angle bisectors. Angle bisectors work very similar to segment bisectors, meaning instead of cutting a segment in half, they're going to divide an angle into two congruent angles. And if you guys think, when we talk about congruent segments have the same length. So if we want to talk about congruent angles have the same measure. So you might want to write that down on your paper. So congruent segments have the same length, but congruent angles have the same measure. So if I know that something bisects it divides it into two congruent angles, then what I'm left with is two smaller pieces that are the exact same length, or the exact same measure. See, I'm still stuck on segments. So this angle right here, green angle, and blue angle would have to be the same. So my only option then is setting them equal to each other versus adding them together and setting them equal to something else. So 6x plus 14 is equal to 3x plus 29. So I would subtract 3x from both sides and get 3x plus 14 equals 29. I can subtract 14 from both sides and get 3x equals 15. So we're actually getting x equals 5 again. And again, pause the video if I'm going too fast. This is just all algebra now. This is the geometry part. This is the algebra part. Then you would plug it back in to find the measure of angle ABC. Now this one's actually tricky because ABC is the entire angle. So you would need to plug x back into both and then you would add them together. But this can also verify that you did it correctly because you better get the same measure. So if we plugged it into this one, 6 times 5 plus 14, 6 times 5 is 30, plus 14 is 44. So I hope I get the same thing here. 3 times 5 is 15. 15 plus 29 oops, equals 44. So we are good. So then the whole measure of ABC, 44 plus 44 is 88 degrees. We can put the degree symbol above there. So that is the gist of measuring angles, guys. We are going to practice next week we're going to practice using a protractor, and we're also going to play a game online to practice approximating angle measures. So this was just the basics. Now you do have 1.5 homework on big ideas. So go ahead and use your notes and do that 1.5 homework on big ideas. I will see you guys next week.